Welcome. In this video I'm going to show you how you can perform an exact multinomial test of goodness of fit using R and the stikpetR library. If you don't want to use my library, I have a separate video on that. The R version that I'm running is 4.3 and it comes with the packages, these packages over here. I'm using jupyterlab, but all of this should also work in, for example, RStudio. I'm not going to explain too much on how exactly what this test does or if you should be using it. I'm just going to show you, if you want to use it, how you can actually get the results. To show this, I need some example data, and I'll be using readcsv to load in some student statistics data. And I don't need all of it. I'm just going to be using the location as the example just to show the first few. There are a few over here, and as you can see, there were actually only 3 locations. There are no other ones later on. To get a real quick first impression, you can simply use table, and then you get a nice frequency table, and indeed there were only 3. So 16 students are from Rotterdam, 22 from Haarlem, and 17 from Diemen. Now to use my library, it's not available on CRAN, so you will need to use DevTools and then install from my GitHub. So if you run this, it should install, and once you install it, you can use it just as any other library. The function of interest is TS, short for test, and then multinomial, and then goodness of fit. It requires the data to be actually entered, and if you like, you can actually also add expected counts. And otherwise it will simply get that from the data. It will simply sum up all of these and divide it over 3 in this case. Now we can simply run this function and we get a few different results. We get, or actually one result but different output. We get the P observed, which is the observed probability of the frequencies as we have them, how many combinations it actually ran, and the most important one, the p-value. It also shows a small description of the test. The p-value is the probability of the frequencies as in our sample, or even more extreme, if in the population the categories would be equally distributed. Now if this is below 0.05, we usually reject that assumption so that they would be equally distributed, but in this case it's not, so we leave it as is. In the other video, I'll show how you can do it with the EMT library and the xnomial library, and also even if you don't want to use any libraries at all, I also have some code for that. Alright, well, I hope this was helpful, and thank you for watching.